Hello everyone. In this video, we will discuss about what are the basic concepts of coordination chemistry and how we can give the nomenclature of coordination compound. We will discuss in this present video. Now, what are the learning outcomes of the present video? So, after studying this lecture, you shall be able to understand the important terms like what is complex ion, how we can define ligands, coordination sphere, what is coordination number in case of coordination chemistry, that we can discuss in this video. And we will also know the classification of ligands, understand the rules of nomenclature of coordination compound that we will discuss in this video. Now, what are the basic terms, important terms which is utilized in the coordination chemistry? Now, in the few slides, we will discuss some of the important terms that is utilized in case of coordination chemistry. Now, first term is double salt. How we can define what is double salt? Basically, a double salt is a salt that contains more than one cation or more than one anion in it. That is called as double salt. Or we can say that those compounds which exist as a stable compound only in a solid crystalline state, and when they are dissolving into the aqueous solution, so they can dissociate into its individual ions, so that is referred to as double salt. And these compounds, they do not lose their identity when we are dissolving them in aqueous solution. That means they will give their individual ions when we are dissolving in the aqueous solution. Now, some of the examples of double salts includes like we have potash elements like Al2SO4 का thrice dot K2SO4 dot 24S2O, in which when we are dissolving potassium alum in aqueous solution, so that will dissociate into the aluminum ion, sulfate ion, potassium ion separately in the aqueous solution. Similarly, we have another example, that is potassium sodium tartarate, more salt, like we have FeSO4 dot NS4 cathode SO4 dot 6S2O. If we are dissolving more salt in aqueous solution, then it will separate into ferrous ion, sulfate ion, ammonium ion in the aqueous solution. So that means they do not lose their identity, and they will give the test for individual ions as we have test for individual ions. So double salts, ions present in double coils, they will also give the test for individual ions. That means they do not lose their identity. Now, second term is the what is coordination a complex compound? Basically, those compounds which exist as a stable compound in the solid state and they lose their identity in the solution. That type of compounds are referred to as coordination or complex compounds. So, in complex compound, we have a central metal atom or ion which is bound with the surrounding electron pairs that we call ligands through a coordinate bond, and these compounds are also known as metal complexes because of the presence of complex ion. Now, what are the examples of complex alloys? That is, we have potassium ferrocyanide, in which we example formula is K4 efficiencies, in which we have this is the counter ion, that is potassium, it is having positive ion, and this is the present portion is in the coordination sphere, Fe6, that is the complex anion. Similarly, we have sodium nitroprusside, Na, FeCN5, NO dot twice H2O. So that is also example of the coordination and complex compounds. Now, what is complex ion? How we can define complex ion? Basically, complex ion is a positively or negatively charged species which contains a central metallic atom or ion surrounded by a suitable number of ligands. Like we can take example of coordination compound like we have CO and H3 6Cl2. So in this case, we can see that this Cl, it is existing as a counter ion outside the present outside the coordination sphere, while this CO and H3 6, it is present in the form of complex cation. As we can see, it is CO and H3 6 2 plus, that is representing as a complex cation. It consists of the cobalt, which is surrounded by the six ammonia molecule that acts as a ligands with they are donating an electron pair to the cobalt atom, and they are making a coordinate bond with the cobalt. So this is the complex ion. Now, how we can define ligands? Basically, ligands, they it is a Latin word which means ligere. Yeah, it is means that to bind. It is a molecule or ion which surrounds the central metal ion, are capable of binding to central metal ion by electron donation. That means they have extra electron pairs with them through which they can make a coordinate bond with the central metal atom, and so that type of species are referred to as ligands. And the atom in the ligands which donates the electron pair is called coordinating atom. Yeah, we can say it is the donor side. And a ligand may contain one or monodonor atom depending on the which type of ligands we are taking for making compound. And the number of donor atoms through which a ligand is binds to a central atom, that is called as denticity of that ligand. Now, what is coordination sphere? The central atom, along with the surrounding ligands, are enclosed in a square bracket and form coordination sphere. The part which is present outside the bracket, it is called as ionization sphere. Yeah, that we can say contour kind. It is ionizable in solution. For example, if we are taking the K4 Fe6, in which this K4 is referred to as ionization sphere, yeah, we can say that is the counter ion, while Fe6, it it is enclosed in a square bracket. That means it is the coordination sphere for this complex compound. In this case, FeCN4 that we discussed, that is the coordination sphere. And what is coordination number? Coordination number refers to the total number of coordinate bonds which is formed by the central metal ion with the ligands, yeah, through which ligands are bonded with the central metal atom. That number is referred to as coordination number of the central metal ion in case of complex coordination compound. For example, if we are taking the example of CuNH3 6Cl2 and K3CrC2O3 thrice, so there are six coordinate bonds are found between the ligands and the certain metal, and that's why coordination number of copper and chromium in this case is a 6. In this slide, we will discuss about classification of ligands. So we can classify ligands on two bases. First, on the basis of mode of bonding, and second, on the basis of mode of number of donor atoms present in ligand. So first, we are taking how we can classify ligands on the basis of mode of bonding. So it can be of two types on the basis of mode of bonding. That is classical or simple ligands, and second one is non-classical pi bonding, yeah, we can say pi acid ligands. First, what is classical or simple ligands? Basically, these ligands have a lone pair of electrons that can be donated to central metal atom or ion. So that type of ligands are called as classical or simple ligands. For example, we have S2O, F minus, NH3, etc. Secondly, if we will discuss about non-classical, yeah, pi bonding or pi acid ligands, then we can classify them. These ligands may or may not have a lone pair of electrons, but they have essentially they should possess vacant orbital for making pi bonding. So that type of ligands are referred to as pi bonding or non-classical, yeah, we can say pi acid ligands. For example, we have carbon LCO, CN, CTH4, C5, S5 minus, etc. Now come to the second classification of ligands. On the basis of number of donor atom presents in ligands, we can classify ligands in following categories. First, that is monodentate or unidentate ligands. That means the ligands which possesses only one donor site present in it. That type of ligands are called as monodentate or unidentate ligands. Some examples like we have Cl negative, OH minus, CO, NH3, etc. And some monoligands possesses two donor atoms, but at one time they can only make a coordinate bond with only one donor side. So that type of ligands are also referred to as ambidentate ligands. For example, if we have SCN, that if it is involves the bonding through sulfur, so that is referred to as thiocyanate. It will make a coordinate bond through sulfur atom. And if involves the bonding through nitrogen atom, then in case of NCS, that is referred to as isothiocyanate. So that type of ligands are known as ambidentate ligands. Now come to the multidentate and polydentate ligands. So what are multidentate and polydentates? These ligands which possesses more than one donor sites present in them, that type of ligands are called as multidentate or polydentate ligand. And depending upon the number of coordinating donor atoms, these can be bidentate in which we have two number of donor atoms, tridentate in which we have three number of donor atoms, tetradentate in which we have four number of donor atoms, pentadentate in which we have five number of donor atoms, and hexadentate ligands in which we have six number of donor atoms present in case of multidentate or polydentate ligands. So these are the examples of bidentate ligands like we have ethylene diamine. In this case, these two nitrogen atoms, they are the two donor atoms present in case of this one. So these are the bidentate ligands like we have acetyl acetonate, oxalate ions. So these are the examples of bidentate ligands. Similarly, these are the various other examples of tridentate ligands, tetradentate ligands, and hexadentate ligands. The hexadentate in this case we have EDTA. So it can also act as a flexidentate ligand. What is flexidentate ligand? In which we have more than one number of donor sites are present in case of ligands, but depending upon the conditions, it can utilize 3, 4, 5 donor atoms to make the coordinate bond with the central atom. So that type of ligand which have more than one donor atom present in that, but depending upon the conditions, they can utilize their number of donor atoms. So that type of ligands are referred to as flexidentate ligand, as we have EDTA, because it is normally hexadentate ligands, but it can utilize 3, 4, 5, 6 number of donor atoms depending upon the conditions. So that is the example of flexidentate ligands. When two and more donor atoms of covalent ligands bind simultaneously to a metal atom and a ring structure, so that type of structure is called as chelate rings that is formed, and these ligands are called as chelatic ligands, and the compound formed by these ligands are called as chelates compound. For example, we have oxalate anions that will act as a chelating ligand, as we can see in this case FeCO2 3 minus. In this 3 oxalato, they are making a coordinate bond with the iron central atom. So that is representing that they are making a ring structure along with the making a bonding with the iron atom. So that is showing the chelate type of compounds. Now come to the nomenclature of coordination compound, how we can give naming of the coordination compound. So there are some basic rules that can be utilized for that should understand for how we can give the nomenclature of the various coordination compounds. So we can say that the systemic names of complex compounds are basically based on the rules which is recommended by the International Union of Pure and Applied Chemistry, that is IUPAC. So what are the rules? That first, the cationic part of the compound is named first, followed by the anionic part. For the second, the ligands names are written in the alphabetical order before the name of central metal ion. There should be no space between the name of ligands and the name of central metal ion. And numerical prefix like we, di, tri, tetra, it should be indicating the number of same kind of ligands if it is present in case of coordination compound. However, prefixes are not considered for determination of alphabetical order. And the oxidation number of central metal ion is indicated in parentheses by a Roman numerical, and no space is provided between the name of metal and the parentheses. Another rule is that if the central metal ion forms an anionic complex, then we have to put 8 words at the name of its anion, and the name of negative ligands it ends with O, name of positive ligands and with EM, and the name of neutral ligands are written as such. Another rule is that if we are having a bridging ligands, which should be indicated by the word mu before the name of such ligand and separated from the rest of the complex by a hyphen. And if the same ligand is present as bridging ligands and non-bridging ligands, the bridging ligand is named first, And for ambient ligands, the point of attachment through which it is making a bonding with the central metal ion, it is indicated by mentioning the symbol of the atom in parentheses after the name of the ligands. In case of geometrical isomers, they should be designated by the term cis or trans, while for optical isomers, they should be represented by the symbol plus or small d and minus or small l to indicate the dextro and levo rotatory forms of compounds. And abbreviations can be utilized for giving the names for complex ligands. Suffix "-ine" is added with the name of complex ion. In case of polynuclear complexes, bridging ligands are named first, and the metal bonds, if present, are indicated in parentheses after the name. This is the example for this type of example. So these are some of the rules that can be utilized for giving the names of coordination compounds. And these are the some of the examples that we have shown here, how we can give the nomenclature of the different coordination compounds, like we have AgNH3 twice Cl. And how we can write on the basis of rules as we have discussed in the previous slide. We can write its name because we have two amines in this case. So we can write diamine silver first, because in this case silver is in the plus one oxidation state, and chloride, and we have to give the space between the this coordination sphere and the outside part. The name is diamine silver first chloride. If we are taking another example, like we have PTNH3 twice ClNO2, we can give, because in this case we have NH3 ClNO2, so we have to put the ligands in case of alphabetical order. So that's why, because we have two ammonia molecule, that's why we will put di here. So diamine chlorido, or we can write chloro, nitro, platinum, because central metal ion is platinum, and it is in the present in the second oxidation. That's why we put the second in the parenthesis by showing Roman number for oxidation step. The name for this compound is diamine chlorido nitro platinum second. If we are taking another example, like we have CONH3 S4, in this case central metal atom is cobalt, which is having four ammonia molecules within the coordination sphere, while we have sulfate is present outside as ionization sphere. So what is the name of this one? It can be written as like tetramine copper second, because copper is in present in the second oxidation state. That's why we have put the second in Roman numbers in the parentheses after the name of metal. So tetramine copper second sulfate. Similarly, we can give the other examples. These are the names of the other examples. Now, what is the summary of present video? We have discussed about the important terms, like we have what is how we can define complex science, ligands, coordination sphere, what is coordination number in the coordination chemistry. We have discussed about the classification of ligands. We have discussed in two ways: on the basis of bondings, on the basis of number of donor atoms presented. In that case, we have classified ligands, and we have also understand the rules for nomenclature of coordination compound. And by utilizing these rules, we have give the shown the some examples how we can write the names of the coordination compounds in this. These are some of the practice questions that can be utilized, that can be solved by using this video. These are some of the references that we have utilized for making this video. Thank you for watching this video.